Hello, Anthropology 141L Laboratory students, and welcome back. Today's mini lecture concerns the Cenozoic. Right? So we'll be trying to talk a little bit about the paleoclimatic conditions as well as life in the Cenozoic. I have attached a paper which will appear right below this video on the Cenozoic for you to read and gain information to help you fill out your timeline. So what you want to do with the timeline is take the amount of inches that you have left or space that you have left, commit it to the Cenozoic, and divide it up into the major epochs of the Cenozoic, right? Beginning with the Paleocene, Eocene, Oligocene, Miocene, Pliocene, Pleistocene, and finally the Holocene. I've attached a chart. If you look down on this page, look down a couple, and you'll see the actual chart that I have attached there so you can get the timeline, right, when these things happen. Okay. Now, one thing I want to talk about is the Cenozoic in climatic terms. There's also a chart on this page, and you can see that with the green lines. It shows you the climatic trajectory of the Cenozoic. And the first thing to notice that is that when the Paleocene starts, it is much warmer than it is today, right? Those are temperatures in centigrade, right? So, we're talking about an Earth which is on average, 18 degrees centigrade warmer than it is now, a warm, soupy Earth. And then it spikes at just about 50 million years ago, which we call the Eocene thermal optimum. And that's when the biomass on Earth is radiated up to where nearly the poles are right now. And these are the situations in which mammals are evolving in the Cenozoic, and of course, primates too. Now, as concerning primates specifically, I'm going to attach a different reading for you on Thursday. And that's when you're going to do the primate evolution overlay on top of what you're going to be putting in as a generalized sort of evolutionary sequence of different mammals. All right. Now, this chart that you're looking at, when you're thinking about how do we know what we know? Well, here's the thing, is that is just a reflection of the relative relationship between or proportions of two different isotopes of oxygen which are in the atmosphere. We have a light oxygen O16 and a heavier oxygen O18, right? And what happens is during cold periods of the Earth, the O16 is always going to evaporate before the O18, into clouds. Then it goes across the continents, rains down, and if it's cold, it gets locked up into ice sheet. So the O16 never flows back into the ocean. So marine organisms are building their shells, their calcium carbonate shells, utilizing higher ratios of O18. So that green line is just tracking those fossilized marine organisms, the concentration of O18 in their shells through time. Now, we can get a graph like this, which shows the whole overall view of Earth, or we can get graphs like this showing specific changes around specific continental margins, right? This one's a generalized overview for you to work at. So on your chart, I'd like to have some indication of what the temperature of Earth is doing, because as we proceed, it's going to make a lot more sense to why primates are emerging and specifically why us. One thing you want to think about also is the last maybe 5 to 8 million years of Earth history. Notice the climatic changes that are happening there, beginning to oscillate faster and faster and faster, which you don't see anywhere else in the Cenozoic, and in fact, probably never anywhere else throughout the entire history of the Earth. In fact, the last 8 million years, it's just been moving from one ice age and freeze thaw, up and down, at regularly increasing oscillations. And that's going to produce an important effect. And I will go into that under the next mini lecture. But for now, let's get this data down. You read the overview of the Cenozoic mammals. You capture the data and images that you want and get those laid out in the chart. And I'll have a lecture update to you probably tomorrow evening. Take care.